This simple problem teaches the students how to get values of an acceleration from the graph of the velocity versus time. Having the velocity versus time graph, in this graph we have three different intervals that give three different accelerations. The first interval from time t equals 0 to 2 seconds, we got at t initial and t final the same velocity, which is minus 6 meters per second. And from the definition of the acceleration, as we have delta v over delta t, and that is v final minus v initial divided by the time interval. And we have here initial and final velocities have the same value. So that gives us an answer of 0 for the acceleration. And when you plot the acceleration versus time, this interval from 0 to t is obviously 0 in the acceleration versus time graph. For the second interval from time t initial equal 2 seconds to t final equal 5 seconds, where we have this straight line with a negative slope, with a positive slope. So we get t initial of 2 seconds that corresponds to v initial of minus 6, while t final of 5 seconds that corresponds to v final of 8 meters per second. So the difference between the final and the initial, it's 8 minus 6, that's 8 plus 6, divided by 5 minus 3, 5 minus 2, which is 3. So we got an answer of that. It's around 4.6 meter per second square. That's the acceleration in the second interval. The third interval between 5 seconds and 7 seconds, we're going to get actually the same answer as the first interval, that is 0. In this problem, it is an exercise actually to let you practice on using an equation for a particle moves along the x-axis in order to get the average acceleration, instantaneous acceleration, and some other information like the time at which the object is at rest. To do that, we need to apply the relations known for the average acceleration and instantaneous acceleration, and that's coming next. To find the average acceleration, simply write the formula as we did in previous examples and problems, and then to find the initial and final velocities, we got an equation for the position as a function of time. So to get the initial and final velocity, we need to take the derivative of this equation, and we got that equation, which is 6t minus 2. And this equation allows us to find the initial and final velocities. To do that, simply just substitute the initial time with 2 seconds and the velocity equation to get an answer of 10 meters per second. Similarly, to do that for the final time, to get a final velocity of 16 meters per second. And then these two values together with time, initial and final, put them into the formula above, we got an answer of 6 meters per second square. That's the answer for the acceleration with a positive sign. Okay, which means that we have an acceleration in this case when the particle is moving along the x-axis. To solve for part B, we need to find the instantaneous acceleration. Again, the derivative of the velocity with respect to time gives us the acceleration, and the equation for the acceleration, to get it, we have to take the second derivative of x versus time, and the answer is 6 meters per second. This answer is also positive. It means in the direction of motion. And to get the velocity, the time where the object is at rest, you just put in this equation v equals 0, and you got a time of t equal 2 divided by seconds by 6, that is 0.33 seconds. A red car travels along the straight road with a constant speed of 15 meters per second, and it passes a parked police car. It means a police car was at rest, and the ladder starts to accelerate with 2 meters per second square in order to overtake the red car. You need to determine the time interval required for the police car to reach the red car, and then to determine the speed and the total displacement of the police car as it overtakes the red car. Well, this diagram shows the whole picture. This is the police car as he watched the red car at t equals 0 and an initial position of x equals 0. The police car initially was at rest while the red car was moving with speed, constant speed, all the way along the x-axis. However, the police car starts to accelerate with an acceleration of 2 meters per second. In order to overtake the red car, is going to catch us somewhere here at delta x. Obviously, both they will reach at the same displacement and at the same final time. In order to meet in here, we need first of all to find the time interval from the initial position here up to the final position. What is the time? So we need to find t final, because t initial is considered to be 0. To do that, we have to remember that they got the same displacement for the police car and the red car, and the same time interval when they meet together. But what we have here, we have actually two equations. One for the displacement of the police car, as long as the car is moving with constant acceleration. So we use this relation, the product of initial velocity by time plus half a t square. We substitute the acceleration with half and the initial velocity with 0. So we got an answer of t square. So delta x is equal t square. For the red car, actually the acceleration is 0. So we have just delta x equal the product of the velocity of the car, which is constant, by the time. The velocity of the car has a value of 15 meters per second. So we got two equations with the same delta x. We solved these two equations by inserting 15t equals t square when we solve them simultaneously. And from this equation we got t equals 15 seconds. Now by having the time of 15 seconds from previous part, we can find the final speed of the police car by simply substituting all the values in this equation. The velocity initial is 0 and the obtained time is 15 and the acceleration is 2, and we got an answer of 30 meters per second for the speed of the car. To get a value for the final destination, we just substitute back delta x equals v of the car multiplied by the time, and we got the final answer of delta x, which is 15 by 15, that's 2. To get the displacement, we can get the displacement from either the police car equation or from the red car equation. To get delta x from the police car, we simply substitute all the obtained values. That is that's t equal 15 and a equal 2 meters as given, and the v initial is given as 0. So the result is delta x is 225 meters. Similarly, we can get it from the equation of the car, and we'll get the same value as we take the product of the velocity of the car or the speed of the car, which is 15, and multiply that by the time, and you will get a similar answer as expected. It is really necessary here to get a summary of the one-dimensional motion. And as we said before, the one-dimensional motion is classified into two: uniform motion and non-uniform motion. However, the uniform motion is found to be of two types: a uniform motion with a constant velocity, and that is the instantaneous velocity equals the average velocity, and a uniform motion with a constant acceleration, that is the instantaneous acceleration equals the average acceleration.